Hello.
Hi everyone, my name is Gaurav Bansal. I work for Metro Graphics. I'll be presenting a paper on coding a large-scale enterprise application from TCL TK 8.4 to 8.5. Unfortunately, the authors Prashant and Tushar could not make it here today, so I'm presenting this paper on their behalf. So, this is the broader division of the areas where you are likely to encounter some issues if you are coding from 8.5 to 8.4 to 8.5. So if you are using some external packages like vWidgets and AnchorTK, so you might see some portability issues. And then we use an internal package, MTI widgets. I don't know if any of you is using that. And then there are some changes, some issues that you'll see because of the change in behavior of the core TCL TK. And then there are some changes in the TCL APIs that you'll see. And then earlier there were some known issues because of which we were using some custom builds of TK to avoid those issues. And some of those issues are now fixed in 8.5, so we'll know what those issues are. So this is more or less going to be a list of issues and observations that were observed while we were porting from 8.4 to 8.5. So I'll start listing them. So this is the configuration details, the information about the versions that we use, operating systems, and the compilers that we use. So I'll start with the issues. So first of all, the issue was that in button.tcl file, in 8.4, we were using some global variables that were linked to the buttons using the ITCL scope. But this throws a runtime exception in 8.5. So, and this is a known bug for which there was a solution that we use up-level set instead of setting a global variable to work with ITCL. And the next one was that till 8.4, if we try to select multiple files using control button, then it used to throw an exception. But in 8.5, this is fixed, so we don't need to handle this in 8.5. And then there was another issue that there's a lot of data that our application dumps into a file, so that we can compare it with the golden file to check whether there are any failures in the application. So in 8.5, what happens is that if there is any node name that has a hash appended before the name, so TCL 8.5 automatically appends quotes for that name. So because of which a lot of our tests failed. And this is a legitimate use of this. So, I mean, because if there's any name that has the sign appended to it, so if we are trying to eval that name, so the interpreter might consider it as a comment. So this was the right thing to do. So we basically updated the golden files on our end to accommodate this change. And then our application requires that the user should not be able to use the CD command inside the interpreter in certain scenarios. So we explicitly used to prevent it using the info level command where we do not want the user to use the CD command. So what we did was we used to use this info level command and pass it as an argument, the argument -1 to verify that the CD command has been called from within the TK dialog file, because some of the internal commands of TK use the CD command. So, but now this information is available by passing the argument -2 instead of -1. And there is this PWD change that is in 8.4. PWD call to a directory that has been deleted, it used to throw an exception. But in 8.5, it does not throw an exception, it returns an empty list. So if you're using this functionality, you need to replace, catching an exception to checking for an empty string that will be returned by this eval. And another issue was that we were using this particular command. This particular command, this worked fine till 8.4, and everything was getting packed very well. But in 8.5, somehow it does not pack the button frame. And surprisingly, we don't know the reason why this is corrected, but instead of using a single command, if we split the command to 3 commands for the 3 different buttons, then the packing is done fine. And there's a change in signature of this API TCL init subsystems, where the argv0 has been done away, and the compiler notifies this about this. So if we are using this API, we need to change the functions and the arguments that are being passed to this API. Now this is related to the tip 125, where what was required was that if we are trying to tear off any toolbar so that it is now an independent window, that was not allowed till 8.4 because any internal frame could not be converted automatically to a top level window. So, and but now in 8.5 this has been incorporated, and this WM has been enhanced to automatically convert any internal frame to a top level window. So if you are handling it manually on your own to do this before, you don't need to do it now. There was this surprising finding that if we try to dock and undock a window multiple times, it gives a crash. This 8.5, and we found out that this was related because the minus menu option was configured after the first undock operation, and this resulted in abnormal termination during docking process. So we just did this that whenever we are doing all the docking operations, we configure the minus menu option to none, and whenever we are undocking it, we again set it to the corresponding right menu option. Now this is another issue that we found with the 8.5, which was not there with 8.4, that in this MTI wave widget, if we do a dragging, then there is a visible trail seen. This goes away automatically when the dragging operation is stopped or we release the button. But till the time we are dragging it, we see a visible trail. We don't know why this is. We haven't got a solution yet. And as I think most of you might be already knowing, that there has been a change in the availability of minus menu option. Earlier it was available with InterTickle had basically 3 classes that had this minus menu option available, that was archetype, widgets and top level. But now this is defined only for the top level window. And our application uses this custom widget, MTI widgets, and required update to accommodate this change, because we were earlier using minus menu options with other widgets also. And this is what we have observed, that in most of the computationally intensive tasks, though they are on the C++ side, using the same functions with TCL 8.5 are 30% slower as compared to using it with TCL 8.4. So same functions, everything using our application without any changes with TCL 8.5 is approximately 30% slower as compared to 8.4. So, any questions? Yeah.
I think with what you've learned, are you guys still planning on going to 8.5 or?
Yeah, actually, we have some solutions to the issues that we have observed with 8.5. So we might do some patches, try to find out some workarounds. But still, we feel that 8.5 offers a lot more value over 8.4. So, but for us, the performance is the #1 priority. So if we are able to get around the performance issue, we will definitely move on to 8.5. But just in case we aren't, then we might think again.
What APIs do that you're using for processing?
We are actually looking into this. We are still not clear about what exactly the problem is. We are filing the code. We are trying to point out to the exact reason for this, but we are still not yet on it.
The dash menu problem, I think I got that fixed. Patch.
You have it? Okay, that's great.
I'll turn it into a patch on source code.
Yeah, sure.
soon.
Okay, that'll be great. Yeah.
How long did it take, and over how large of a code base?
Our code base is large, that I know. But how long did it take? I don't know, because I was not the one who did this. I'm presenting the paper on their behalf. So, but I think it might have taken something like 4 to 5 months. I suppose. That's a guess. I don't know.
I ported our application, which is fairly similar to theirs. It took me about a month, and the biggest change was getting rid of arrow result. That's what took me the longest time. And I ran into some of these same issues as well. And our code base is about 300,000 lines of tickle and tickle code. And I'm not sure how big the C code is, probably 3 or 4 times that.
Have you noticed performance issues on yours as well? Or
I did not measure performance, so I didn't get that far.
do you use the clock project?
Not much.
That has slowed down.
Yeah, I don't remember using it. We use it when we try to profile a code, so as to figure out what part of the code is taking more time. But in general, in the functionality, no. That is it. I think I saved some time. Thank you.
Now, alrighty, let's have some fun. On my iPhone, do you know what augmented reality is, or what the marketing term means?
Are drugs involved?
No.
Alternate
That's
reality.
So on my iPhone, I've got this little application. And I can hold it up. Let's work out where I am. It'll tell me where there's aircraft. I don't know if you can see that. It's turned the video camera on. And it tells me where there's aircraft. And that, oh, there's one over there. You see that little box come up? I've lost it. It was there. Underneath the aircraft, it actually puts a little box telling you which airline, where it's flying to, flight number. So you just point at it, point at the sky, and it tells you. Well, that's what they mean by augmented reality, at least in the marketing sense. Yeah, that's right. Yeah. There's a good one, good app called, I got this too high, Steve? So yeah, there's one called the Beer Compass that I can recommend as well. All right, so David Rosen and myself had this fun project over the summer. Dave can't be here today, and if you're listening in, Dave, I hope you get better soon. But it was fun, but it was serious. There was a proposed wind farm on Lake Michigan, and it's between 100 and 200 turbines, as we call them. Turbines, as I said here. Depending on the size that they're actually able to source, if there was 10 megawatt turbines, it would be 100 of the suckers. Each was 575 feet tall, and they're pretty close to shore. This is the location of the proposed wind farm. You can see you are there. Looks up the lake. This was the footprint of the initial proposal. Now, as you'll see, that comes rather close to shore. There's a 5-mile scale, so that's what, 2 miles from shore? The footprint's since been reduced, but even so. The interesting thing for me is there's a community of people who sail from Deepwater Lake. Now, I don't know if you know much about sailing, but you can't just, well, I guess you can motor out. But that's an awful long way to have to go down, and Mike's pointed out that just about here, it's pretty shallow. So you're probably going to have to sail up and across and down, or motor up and across and down. You could be going for 20 or 30 miles before you can sail. So the local residents were quite concerned about this. And you can see why when you see the size of these things. And that's not a small device. So local residents were interested to get a feel for the visual impact of these. And to get a feel for the visual impact, you need an accurate representation from arbitrary viewpoints around the coastline. So we looked at ways of doing this, and first thought was, well, we'll use OpenGL and probably buy one of the tickle bindings. TK3D, if you've seen Paul Overmeyer's, what's that?
Your wristband is interfering.
This is interfering with it. I'll hold this up.
Thank you for calling.
Okay, since we're well ahead of time, I'll adjust the equipment now for you. Sorry, Steve.
Actually, Steve, if you put the transmitter on your other side, you won't be sitting between the pads.
It'll be easier than moving my arm, I can tell you. All right, how do I go now?
Just turn it back on.
I did.
Oh, okay, now it's on.
Okay. So Paul Overmeyer, as each month on the wiki, you'll see the TK3D demo of the month. Well worth having a look at if you're looking to do any sort of visual stuff. But before we went down that path, we thought, well, we'll have a look at the consumer tools that are available. And there was two tools in particular from Google that warrant investigation. Put your hand up if you don't know what Google Earth is. Okay, good. I saw a finger. Does that mean you sort of know? You've all probably, well, I imagine you've all used it. It's a 3D version of Google Maps, if you like. And in particular, you can place 3G objects at any location, and you can have arbitrary camera positions or viewpoints to look at them. And the markup language for this is actually in XML. It's called Keyhole Markup Language, or KML. Sometimes you'll see a KMZ file. That's just a zip file containing KMLs. But there's a sister product to it called Google SketchUp that you might not know about. It's a 3D modelling program. So you can make these models and then you can place them within Google Earth and look at them. And there's some interesting ones like the London Eye and so forth. So what we decided to do was two approaches to this in parallel. A standalone version which used the Google Earth program and a TickleTK program to control it and set various parameters. But there's also a Google Earth plugin available for Windows and Mac OS X. And we thought, well, we may as well go and try and do this in a browser as well. Before we got on to programming, we had to do a bunch of stuff. We had to come up with some turbine models. We had to define the footprint of the wind farm, that is the location of all the turbines. The viewing parameters, how far away, how high, what angle, and so forth. And then generate these KML files for each of the viewing locations. Figure out a way of controlling Google Earth in the standalone version, and then validate the visuals to see whether our models are going to be an accurate representation. The turbine models themselves were written in SketchUp, as I mentioned, and SketchUp has quite an active community. A lot of them are architects and that sort of thing, designers, and there's a whole library of models available, including quite a number of turbines. So Dave took these and scaled them and modified them and simplified them in some cases, and we ended up with a DAE file, which is the sort of the export file for these models, which could then be loaded into Google Earth. Then we needed to generate a model for the wind farm footprint. And the way that was done was using the Google Maps REST API to extract an image of a known size from Google Maps, using the geodesy code from the wiki to get an approximation of the pixels per kilometres at that particular location, and then lay out the image of the turbines equispaced on that footprint. And then add as an extra step so that the user could validate that, just lay them out on a canvas so you can see them. And that's the program, the layout program running. You can see that the footprint's changed now, but there's the location of each of the turbines. At this stage it's zoomed to 11. The volume control goes to 11. And we can zoom in and out, and it refetches the image from Google Maps and displays it up there and so forth. So this is a 100 turbine layout, so that'd be 10 megawatt turbines. And you can see how it's equispaced it within the footprint. And then the next thing to do is to generate the KML file for the wind farm itself. And that's done just by substituting into a text template using Tickle. So we have one model for the wind farm, then we need a separate model for each of the viewing points. Some of the attributes of a viewing point, latitude, longitude, obviously, the altitude above the ground level, and then for the camera, the heading and the tilt and roll. So these are the viewpoints we're looking at, up and down the coast. And you can see there that the footprint's actually being overlaid in Google Maps. This isn't in the TK app, this is straight off the browser. But there's also another viewing parameter that we need, and that's the field of view. The field of view is essentially the angular extent that you can see. It can be a horizontal, vertical, or diagonal, but the angular extent that you can see when you're looking at something. So if you start with your arms out like this, and I'll make it quick before it falls off, and bring your hands in, the point at which you see your hands is your viewing angle. And with the camera, and this is a gross simplification, but Kevin's not here to correct me, is he? With the camera, if your viewing angle, like as you zoom in, your viewing angle becomes narrower, but the subject appears taller. So that's important to us. There's another consideration. It's a concept called the design eye position, which is used in flight simulators. Those of you who might have been in the Air Force or are in the Air Force might have heard of this. It's basically the viewing position, and it's a position from which the user will optimally view the interface to get the most realistic perspective or visual perception of the simulation. So what we're essentially saying is that in this case, the horizontal field of view is a function of the width of your display and your viewing distance from it. And typically, on most computers, the width of the display is fixed. And so what we might want to do is play around with the viewing distance to get a good feel. And there's a problem. Google Earth has a fixed horizontal field of view of 60 degrees. And on my little MacBook Air here, 13-inch display, the horizontal field of view is 23.96 degrees. So the result is that the turbines appear too small when you overlay them into Google Earth. And we thought this was a showstopper for a while, and I was spending evenings browsing the web, and I found some guys somewhere in Europe that were using Google Earth to make their own little flight simulator. And they figured out a way around this, and it's really clever. Inside Google Earth is a facility called a photo overlay. And basically, if you look on the right here, you can specify an image and overlay that on top of the Google Earth scene. Now, the intention is so that you might have a map of a nice beach or something, or some location, and you can put an image there of a hotel that you're proposing or whatever. But the cute thing is you can actually put a transparent image. One of the attributes down here is the horizontal and vertical field of view. And if there's a transparent image, then it transforms the Google Earth scene behind by applying those field of view values. So this is the way we can adjust the field of view in Google Earth, a transparent image over the top. So at least in the version I'll show you later, Network Gods being willing, assuming it's an individual user at 30 inches for the screen, 30 inches from the screen, we can just generate the field of view by passing the width of the screen. On my 13-inch here, 24 degrees, as I heard Andreas mention before, instead of 23.96. On my 27-inch display, it's 26 degrees. Just as a comparison, on a 35mm camera, they're not too dissimilar, those figures. 85mm is close to, anyway. So, we've got the viewing parameter, we've got KML file for each viewpoint, we've generated through a Tcl template, and we've got the XML resulting, the KML resulting. That's served up in the browser version, at least, that's served up as a CGI script, so we can just pass in the width of the screen and the distance. And that's what a KML file looks like. It's not too sophisticated, but the thing is I've got a bunch of values, left field of view, right field of view, bottom and top field of view, which are just substituted in at runtime in the CGI script. So, I mentioned before there were two approaches. There's the standalone and the browser. Let's look at the standalone now. It's Windows only, which is a limitation, obviously, but not for everyone. It's there's a Tcl TK program that controls Google Earth. First of all, it finds the location of Google Earth, starts it up, uses TCOM to talk to it. There's various options for the simulations, such as structures that you can put next to it, like the Statue of Liberty or the model of the Edmund Fitzgerald or the Mackinac Bridge, just so you can get a feel for the size of these things. The user can define the viewpoints and the focal lengths that the user wants to play around with, and Google Earth is then controlled by this standalone Tcl TK application. That's not the main focus of what I'm going to show you today, but I wanted to mention it all. Its advantage is flexibility, its disadvantage is Windows only, but that advantage of flexibility, this is more of a workbench when you're experimenting. The browser application takes advantage of the fact that there is a plugin, and its advantage is that it's easy to deploy. You don't need to have Windows, you just need a plugin and it's easy enough to get. It's about 400 lines of JavaScript, so it's not really a large program. And you use Google Maps to choose your viewpoint. This is the program running, and there's the viewpoints. You just click on the one you want. You can zoom in, zoom out, and so forth. as I mentioned before, it uses a typical CGI script to get all the parameters for that viewpoint. And then it uses Google, fires up the Google Earth plugin and flies you to that viewpoint oriented so you're looking to the wind farm. That gives you an idea of what the simulation looks like there. It's probably a little small for those of you at the back, but you can zoom in and zoom out in Google Earth and move around and just change around, get a perspective of things. The thing is, Google Earth doesn't actually allow you to zoom, it just moves the camera position closer to the subject, so it's not a true zoom, but it's all we have. Again, the KML is coming via a typical CGI. So that's a bit of, I've just done a crop and expand to give you a better feel for it. You see the perspective sort of right, it's all good. And we thought, well, we can do a little bit better than this, and put some animations in there. The way these were done was by having multiple SketchUp models, each with the turbine blades at a different angle, a random start position for each, and then a little bit of JavaScript on a timer that just changes to a different model, the next one in the sequence. I've just got two there flipping backwards and forwards. But there was an issue. They still appeared too small. For example, this, when compared with observations of similar sized structures at a similar distance, this is the Mackinac Bridge, which I'm led to believe is up the north end of Michigan. Is that right, Cliff? Yep. Did I pronounce it right?
Yeah.
Did I spell it right? And so this pylon here, the far one, is actually the same size as one of those turbines. And apparently in the flesh, this thing looks, it just